All right, section 8.5 is dealing with angles of elevation and depression. So the first thing we need to figure out is what is an angle of elevation and what's an angle of depression. So an angle of elevation is the angle between the line of sight and the horizontal when an observer looks forward. All right, so when an observer, that means you. So I'm going to draw a little person here. It's my happy little stick figure. So it says the line of sight when the angle between the line of sight and the horizontal. So our horizontal is when we are looking straight across. Okay, that's where your line of sight, that horizontal. Okay, now if we were looking straight at the horizontal. Now picture yourself looking up into the sky. So here's us looking up into the sky. So the angle of elevation is when I'm looking from the horizontal up. Okay, so that's my angle of elevation. All right, so now let's take a look at angle of depression. It's the angle between the line of sight when an observer looks downward and the horizontal. All right, so elevation, we're looking up. Depression, we are going to be looking down. Okay, but remember, everything goes back to that horizontal line, or think of it as like the horizon. So there's my person. Here is my horizontal line. And now picture yourself up on top of a hill, okay? Or maybe at High Rock. And then when you're up there, you're going to want to look down. So now the angle is from the horizon down. Okay? So a lot of times these problems you're going to be looking and saying, okay, where would I be in this diagram, and would I be looking up in the diagram or would I be looking down in the diagram? Okay, so let's take a look at example 1. It says, at the circus, a person in the audience at ground level watches the high wire routine. All right, so here's our person in the audience. A 5-foot, 6-inch tall acrobat is standing on a platform that is 25 feet off the ground. How far is the audience member from the base of the platform if the angle of elevation from the audience member's line of sight to the top of the acrobat is 27 degrees? So they gave us some very valuable information here. The one biggest thing we need to look at, it says the angle of elevation, because see how they gave us two lines. They gave us this bottom line that reaches to the feet of the acrobat, and then they gave us another line that goes to the head of the acrobat. And that 27-degree angle of elevation goes to that top line. So that goes all the way up here to the top. So that means we need to highlight this. We need to use that whole length, okay? Not just part of it. We need to use the whole entire length. So we know the opposite side, we know the angle, and it looks like we're trying to find the adjacent side. So if we think back to this, we're going to have to use SOHCAHTOA because it is a right triangle. SOHCAHTOA. All right, so we know if this is the angle measure we're referring to, we know the opposite and the adjacent. So opposite and adjacent is tangent. Okay, so we are going to do the tangent of our angle is equal to the opposite length over the adjacent length. So we have tangent, our angle is 27 degrees. The opposite side is 25 plus 5.5, because remember that's our total length. The 25, which is the height of the platform that the acrobat is standing on, plus she is 5 foot 6 inches tall. 6 inches is half a foot, so that's where we get the 5.5 from. And the adjacent side, that's our x. All right, so some of you might prefer to put the tangent of 27 over 1 and then cross multiply. So we end up getting, I'm going to take 25.5 and add that to get, I'll make this look a little bit better, over 1 equals 30.5 over x. And now we are going to cross multiply. So we get 30.5 equals x times the tangent of 27. If it makes you feel more comfortable, you may change the tangent of 27 to a decimal here. I prefer to leave it until the last step. That way I get a slightly more accurate answer, but that is completely your choice. Your answer won't be really far. The 1 or 2 decimals might be different. So now to get x by itself, I need to divide both sides by the tangent of 37. I'm sorry, 27. All right, so tangent of 27's cancel. I'm going to switch this around because I prefer my x to be over there. So x equals 30.5 divided by the tangent of 27. And that you can just type into the calculator. So when you do that, you get approximately 59.86 feet. Okay, if they wanted it to the nearest foot, we would say 60 feet. Right, so take a moment. That was actually the only example today. I did shorten it a little bit. There were another example, but we're just doing one. So take a moment, try the 2 your turns. You get to have a little fun with these two and draw pictures. So I will probably go through the first your turn with you to help you set up that picture, because sometimes that's the tricky part. And then for the second one, I will let you guys pause the video, take a moment, try it again, and see how you do. All right, so this first one. Remember I said at the beginning of the year, this is sometimes the most difficult part, is drawing the picture, setting the problem up correctly before you even get a chance to do it. So it says, at a diving competition, a 6-foot-tall diver stands atop the 32-foot platform. The front edge of the platform projects 5 feet beyond the ends of the pool. The pool itself is 50 feet in length. A camera is set up at the opposite end of the pool, even with the pool's edge. If the camera is angled so that its line of sight extends to the top of the diver's head, what is the camera's angle of elevation to the nearest degree? All right, so I was picturing this in my head as I was going. First of all, we have a pool. Oh, I can add color to this. All right, so there's our pool. I'll put our little camera down here. It's not going to look like much of a camera. Okay. Then we have our platform, which goes up. We have the platform is 32 feet. The front edge of the platform projects 5 feet beyond the ends of the pool. So that must mean my platform goes this way. All right, so this platform is 5 feet. And we have a 6-foot tall diver standing on it. Don't worry, my proportions here with my 6-foot tall diver and my 32-foot platform, they're not very accurate. All right, and I think the last thing they gave us, the pool itself, is 50 feet long. So this is a total of 50 feet. So I did the 6-foot tall diver, the 32, the front edge of the platform projects 5 feet. The pool itself is 50 feet in length. A camera is set up at the opposite end of the pool. I have my camera. If the camera is angled so that its line of sight extends to the top of the diver's head. So this is where I'm going to make my triangle. So it is extending to the top of the diver's head. There we go. So that we don't know because that's what we're trying to find. So elevation goes up. So we start at the bottom and go up. That is X. All right, I think we have everything we need here. All right, so if I were to make a triangle now, so my triangle would look like this. All right, and this right here is a right angle because we always assume that something vertical, especially like a person or in this case the platform, it will be perpendicular with the ground even though mine's not completely perpendicular. So let's see the information we know because we know a good bit here. So this whole vertical side or the long leg of my right triangle, it is a total of 38 feet because it's 32 feet with the platform and then our diver 6 feet. So that means this side is 38 feet. All right. Now this short leg here, we know the entire pool was 50 feet, but that platform sticks out 5 feet. So that only leaves me with 45 feet here for that side because I would need to do the 50 minus the 5 to get my 45. And over here I'll put my 32 plus my 6 to get my 38. All right, so now we have everything we need. So we have X. All right, we know the opposite side and we know the adjacent side. So again, if I write out my SOHCAHTOA, which one uses opposite and adjacent? It is tangent again, and it won't always be tangent. So we have the tangent of X, which is our angle, which is the opposite over the adjacent. Okay, so now we need to eliminate that tangent. So the opposite of tangent is tangent inverse. That's how we read that little tan to the -1. But the golden rule of algebra says what you do to one side, you do to the other. So my tangents cancel. I'm left with X is equal to the tangent inverse of 38 over 45. And now this is just a matter of substituting that into your calculator. So you would have to hit second tangent to get tangent inverse. And you do that of 38 divided by 45. Let me change these to approximately 40.18 degrees. Okay. All right, now the your turn B is talking about an angle of depression. So I am going to help you set that one up too now that I look at it. But you guys will have some practice work. So you'll get practice with it. All right, so we have a roller coaster car is at one of the highest points. It drops at a 63-degree angle of depression for 320 feet. How long of a vertical distance was the drop? All right, so let's draw with my great artistic skills. Here's a hill for a roller coaster. All right, I'm gonna draw a shaky little roller coaster car. Here's our person. The arms up in the air, their hair blowing in the wind. Look at that. Beautiful. Okay, it says it's at one of the highest points and drops at a 63-degree angle of depression. So we have to be careful here. So remember, depression goes from the horizontal. And since I'm drawing it here at the top of the hill, because it said what's the vertical distance was the drop, and you don't drop from eye level, you drop from where the cart meets the top of the hill. All right, so 63-degree angle of depression. So there's my horizontal. Remember, the 63-degree angle goes from there to another line. So I'm going to draw my line down here. All right, so that's my 63-degree angle. Now from here, you have a couple different triangles you could create. I'm going to create them with two different colors. If we want to use that 63-degree angle, okay, and we will say, I know I drew my line past that, but we're going to say the bottom is here. So I'm going to draw my triangle there. So now here is my right angle, which means this is 320 feet, the hypotenuse is, because it drops at a 63-degree angle of depression for 320 feet. So we'll say, that's our drop there. How long of a vertical distance was the drop? So over here would be my vertical distance that we're using. All right, so now pause this, see if you can pick out the right trig ratio to use and solve the problem, and then come back and check. All right, so since we have our angle, we have the opposite, and we have the hypotenuse. Let's see if I can do this down here. So, we have opposite and hypotenuse, that is sine. So we're going to do the sine of 63 is equal to the opposite over the hypotenuse. I'm going to multiply both sides by 320. So x is equal to 320 times the sine of 63. And when we do that, that is approximately 285.12 feet. So the vertical drop is 285 feet. It's a pretty significant vertical drop. All right, so now I'm going to, and you only have to do this one way, but sometimes people don't draw the triangle here. They draw it here, because that is the vertical drop. They think of the vertical drop right underneath, which is 100% fine. I'm just going to show you there's two ways to do these problems. So now there's my new triangle. This right here is still my right angle. This is my hypotenuse, which is 320 feet. We still have to find this vertical distance. However, notice how this is a completely different triangle. So I can't use that 63-degree angle anymore. I have to find this angle. Well, those two angles create a right angle. So to find this angle, I'm going to take 90 minus 63. Okay, and when we do that, we end up getting 27. So now I can use this green triangle, but according to this green triangle, now I have the adjacent and the hypotenuse. So adjacent and hypotenuse is cosine, so I'll do this work over here. So now I have the cosine of my 27-degree angle, because that's the one that goes along with my green triangle, and that is equal to the adjacent, which is x, over the hypotenuse, which is 320. Same thing, multiply both sides by 320. And when you substitute that into the calculator, guess what you get? You get 285.12 feet. So you get the same answer. There are just two small differences. One, you have to be very careful as to which angle you are using. I can't tell you how many times people draw this green triangle, But then they end up using, instead of 27, they use 63 because they think depression's that angle going down. But you need to remember it's going down from the horizontal line down. Okay? So that's one thing to be cautious of.